Well, good morning, everybody. So you're in for another bumpy video. My apologies. Um, so I'm actually going to post the problem up in the website so you'll be able to read it. And I have to hand type in the tables. So brand 1, brand 2. Now, and you really need to treat it as before minus after. And the differences are what are going to be important in terms of how to get the test statistic. So I'm going to pull away from you, or pull away from the computer screen, and I'm going to show you how I did this. So I'm on the handy dandy graphing calculator, and I go to stat, edit. I'm going to edit a list. And in L1, I put all of the differences, okay? So I have to put differences in there. I don't put the values from brand 1 and brand 2 in there. I put the differences in. Now, once I have those in, I'm going to go to stats, and I'm going to arrow over to tests. I'm going to go to t-test. We're basically tricking a 2 sample into a 1 sample because they're dependent. And you want data highlighted, not stats. And in the null, we're claiming that, or we're assuming that it's 0. And where that comes from, I'll pop back up here if I can real quickly scroll down. There it is. Based on these data, can the consumer group conclude that the mean tread wears of the brands differ? So the claim is actually going to be on the alternative hypothesis. I'm going to scroll this up. So the null is if they're the same, so that's the equal, and then their differ is not equal. So one can be larger than the other or vice versa. So the claim's on the alternative, but this piece here, that mu sub d equals 0, is that 0 right there. Now the list we put our differences in is L1. We leave our frequency list as 1 because each one of the data points only appears one time, but that's really, you can create a frequency list which is L2 if you have a bunch of the same differences. We won't use that, don't worry about it. So you want your frequency to read 1. And then it's the not equals, and then we're just going to arrow down to calculate. I'm going to hit enter. So here's a couple of pieces of information for you. So this is your test statistic, and this is your p-value. Now on this problem, they only ask for the test statistic, but I'm going to report to you the p-value is 0.11. And since our p-value is larger than our alpha, which is 0.05, you're going to fail to reject the null. We're going to operate as if the differences are the same, or the tread wear is the same. We have the mean difference right there, so mu sub, or the d bar in your in the description or in the problems would be that 0.042, and the standard deviation of the differences is this value right here. Now your n is 10, but your degrees of freedom is n minus 1. And so I'm going to travel back over here, and we're going to put in the information. So we're using a t-test. Degrees of freedom will be 9. We put our test statistic right there. Now, there's 2 ways to get the critical values. I'm going to show you over here. I'm going to click on our calculator, and this is to generate the probability. This is to generate the critical value. So I'm going to click on that. In the left tail, it's 0.025, and our degrees of freedom are 9. And I'm going to hit enter, and it's going to give me the 2.26157. Now, I have to make sure that I understand that there's both a left side and a right side. So one's negative, one's positive, okay? Now, in all of the work that I've done, when I do the videos, I draw the distribution and I put the critical values in. So you'd be expected to show both those. And on the test, you'd be expected to report the p-value and show the test statistic. Okay, now, let me very quickly draw this just so you see it. And I'm going to put the phone down for just a moment. My apologies for that. So negative 2.26, 2.26, and then here's my negative, or my positive 1.73139. Oops. Negative and positive 1.73139. Okay, so this is a two-tailed test. So we draw both critical values, and we draw the test statistic and its flip-flop, because on a two-tailed test we draw it both ways, because the wording of it is actually as extreme as this one or more extreme, but you have to consider distance going both directions. So in a two-tailed test you would have both regions. So we're landing in the fail to reject region. Okay, so the three parts of the conclusion would be, and I'm just going to write this here, I apologize, this is very informal. Fail to reject the null at alpha is equal to 0.05. And then the third part, we talk about the claim. I'm going to travel back up here, and remember our claim was on the alternative, but the alternative is getting the scratch. We're operating as if the null is good. So there's insufficient evidence to support the claim, and so the last piece we say is insufficient evidence, and we're good there. Okay, I hope that helps.